Okay, so this is the last video of the day, and now we've looked at 5 different sorting algorithms. When would you actually use each of the algorithms? So it's difficult to choose a sorting algorithm that fits all use cases. Therefore, it's really important to know a number of algorithms, hence why we've done 5, and also to provide some guidance as to what algorithm to choose in what case. Insertion sort and selection sort are actually fine. They're easy to implement, and if you don't have a built-in sorting algorithm, whatever your system you're using, which nowadays can be quite unusual, but it could happen, and you're only going to be sorting like 50 elements or so, then they're actually quite good, and it is what you should use, because things like merge sort actually have quite a big overhead in setting up the data structures. So it can be really useful to use insertion sort in that case. Insertion sort actually is also very effective when sorting nearly completely sorted arrays, because it just looks through and says, okay, where's that number going to go? If the array is 100% sorted, then insertion sort actually becomes big O N and very, very efficient. So if you think this data might be mainly sorted, it might be a good one to consider. For larger arrays and cases where you don't think the data is sorted, you want to use merge sort or quick sort. These are both much faster than insertion sort and selection sort. You might think that merge sort is better because it's the one that's got the guaranteed O(n) log n worst behaviour, which is far better than n squared. In reality, people tend to use quick sort because the way that parsers and computers work, it tends to be implemented efficiently for that sort of algorithm to work. So actually, in reality, quick sort is often the one that's built into, or a variation thereof is often the one that's built into sort data. If the data range is known and is not too huge, remember that's our big O n plus m, where m is the size of the data range, you could consider using a bucket sort, and that can be quite good in that scenario. Okay. So that's kind of the rules or thumbs or the heuristics as to when you should use different algorithms. What I'm going to ask you to do now is to use all the implementations and come up with a test bed and really think about what do I want to test and how am I going to find out which algorithm I should use when. And you'll be very glad to know, or I think I am, so I've been speaking for about half an hour between the different videos. This is the last video for today. And next week, you don't have any classes in this area, you're just in business management all day. And then you've got a double class the week after, so you'll hear from me then. I hope you have a good rest of the day and that you now feel that you understand sorting a bit better. Take care.